now that we've been introduced to all the ideas of Bayesian estimation, let's tie it all together and do an example. So in this example, we'll be working on finding a posterior distribution and finding the Bayes estimator for a parameter. All right, so in this example, we have a random sample of size n. Remember, random sample means IID, and it's from a Poisson distribution with some unknown mean lambda. All right, so lambda is our parameter, and since we're in the Bayesian setting, we need to have a prior distribution for lambda. So let's choose lambda to have a gamma distribution with parameters alpha and beta. And alpha and beta are known, we chose them. It could be like alpha equals 2, beta equals 7, or something like that. All right, so we have our prior distribution, and now the last thing we need for the Bayes estimator, we need to know our loss function, because remember, the Bayes estimator minimizes the expected loss. So let's choose a loss function that is the squared error loss, or in other words, theta hat minus theta squared. All right, so using that loss function, let's find the Bayes estimator and the posterior distribution for lambda. All right, first thing we want to do is translate from sentences into equations. So this piece, we know that we have a Poisson distribution. So what does that mean? We know that the PDF of each of these x's equals e to the negative lambda, lambda to the x over x factorial. So this means that our likelihood is equal to the product of these PDFs. All right, so we know that our posterior is likelihood times our prior distribution, but really all we need is to have something that is proportional to our likelihood distribution. So in other words, down here we have this xi factorial. We don't need it, it's just a constant. So really we can write our likelihood as proportional to e to the negative lambda, lambda to the xi. Okay, let's take this one more step. We know that if we're multiplying e to the negative lambda n times, then this is equal to e to the negative n lambda. And we know if we have the product of lambda to the xi, that's the same thing as lambda to the sum of the xi. All right, so now we have our likelihood already. We can go ahead and think about what our prior distribution tells us. Okay. So if we have a gamma distribution, we can just go ahead and look that up in the back of the book or something like that. We have a bunch of constants, including the gamma function in the denominator. So we have the gamma function of alpha, and then we have beta to the alpha in the denominator. And remember, alpha and beta are known, they're constants. And then up in the numerator, we have lambda to the alpha minus 1, and then e to the negative lambda over beta. All right, so there's our prior distribution. And again, these are just constants, so we can drop them. It doesn't matter. All right, so we have our likelihood, we have our prior. Now we can multiply them by each other to get our posterior distribution. Okay, so let's go ahead and plug these in. So our prior, we have the stuff in the numerator, and we're going to just forget about the denominator because that's constants. And then we have our likelihood, which is proportional to e to the negative n lambda times lambda to the sum of the xi's. All right, at this point we can see we have e to the something times e to the something, so we can combine those. And then we have lambda to the something times lambda to the something. So again, we should combine those as well. So we have lambda to the sum of the xi's plus alpha minus 1. And then we have e to the negative lambda times n plus 1 over beta. All right, so now this is proportional to the PDF of our posterior distribution. And remember, I said if we're lucky, we'll be able to look at this and recognize it as a distribution we know. So actually, let's look back to this gamma distribution here. We have parameter to the something minus 1, and then we have e to the negative parameter divided by beta. Now let's look here. We have lambda to the something minus 1, and we have e to the negative lambda, and then times another something. So then that means that our posterior is a gamma distribution. All right, so the first parameter is up here. We have lambda to the first parameter minus 1. So that means our first parameter here is sum of the x's plus alpha. And then our second parameter is, we need to look at the e part. So we have e to the negative lambda divided by the second parameter. Here we have e to the negative lambda times something. So that means our second parameter is 1 divided by n plus 1 over beta. Okay, and if we wanted, we could go ahead and find the constants and everything to make this a proper posterior distribution, but that's fine. We already know that it's a gamma distribution, so we don't need to go ahead and do that. All right, so we found our posterior distribution. Now if we're trying to use this squared error loss to find the Bayes estimator, we know from our theorem from the previous video that we really just need the posterior mean, or in other words, the mean of the posterior distribution. The posterior distribution is a gamma distribution. So if we want to find the mean of a gamma distribution, it's just this parameter times this number times that number. Okay, so then our Bayes estimator is sum of the x's times 1 over n plus 1 over beta. All right, so there's our Bayes estimator, and here's our posterior distribution. So just to quick summarize what we've done, we took all of these sentences and translated them back to math. So we have these equations here, and then we found our likelihood distribution, but really just the likelihood distribution without the constants, because that doesn't matter. So we wrote it like this, and then we got our prior distribution written out, and then we remembered that posterior is proportional to prior times likelihood. So we wrote that out, combined like terms, tried to recognize it as a distribution that we already know. We recognized it as a gamma, so all that we needed to do then was figure out, okay, what's this first number, what's this second number? And it was just a matter of matching up this with this and this with that. Okay, and then once we needed the Bayes estimator, we looked at our loss function, squared error loss. We knew we needed the posterior mean, and so we calculated that.